Mutation is messy. So that's the next thing to learn. So if I say A to B, list, quote X, quote Y, quote Z. I say define B to be cdr of A. So B has the value of YZ. And now if I say set car B foo, can't type. The value of B, as expected, is foo Z, but the value of A has changed also. Okay, so I intended to change B, but I changed A as a side effect because A and B share storage. Now, that isn't always the case. If I said define, I don't know, H to be sentence, quote A, quote B, quote C. And now I say define J to be but last of H. So J is AB. And now I say set car J, quote, Baz. You're going to say, isn't this a data abstraction violation? And yes, it is. I know. And now I say, what's the value of J? It's Baz B. And what's the value of H going to be? Baz BC? No, it's ABC. Because H and J, it turns out, don't share storage. If I had said but first up here instead of but last, then they would share storage because but first is just cdr for sentences. And so it would have worked like the previous example. But last has to make a copy of its argument. And why is that? Because if I have A, B, C, and I make a sentence out of them, and now that's H. And now I want J to be just AB. I can't use these pairs. I can't reuse these. Because we can't have this both point to C and also be an empty list, right? Which it would have to do if H and J both pointed to the same place. I can't do that. So instead what I have to do is make new pairs for J. So sometimes you're sharing storage, sometimes you're not sharing storage. If you're sharing storage, then mutating something may affect other data. If you're not sharing storage, then it won't. So this sort of thing, as you can probably imagine, makes it easy to have bugs in your program. So one last pitch for functional programming. If you can possibly do something functionally, you avoid having to think about this ugly stuff, about whether two lists that look the same are actually sharing the same pairs, or are, as in the first example, or different pairs even though they have the same elements as in the second example. Right. In particular, why didn't I just say quote parenthesis XYZ here? I would have gotten the same result, a list of X, Y, and Z, and it would have been less typing. because there's a rule in Scheme that says you're not allowed to mutate a quoted list. And the reason for that is the Scheme standard allows an implementation that wants to use storage very efficiently to, whenever you quote something, look and see if it's already made that particular value, that particular quoted list. And if so, give you a pointer to the very same one instead of making a new one. So that would happen, for example, if you have quote, parenthesis, blah, 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 inside a procedure, and you run that procedure once, and you create that quoted list, and then you run the procedure again, it might as well give you the same quoted list instead of another one. On the other hand, implementations that want to be straightforward are also allowed to create a new list every time it sees that quoted value. Therefore, you don't know with a quoted list whether it does or doesn't share memory with something else. If you write a program that depends on that uses setcar or setcutter on a quoted list because you want to be sharing values or because your particular scheme isn't sharing values, sharing pairs between those different things, and then you take your program and move it to a different scheme interpreter or compiler, it stops working and you'll be upset. So the rule is you're not allowed to modify a list that was made by quoting it. You have to call list or call cons or something to make lists that you're going to modify. Okay.